In this video, we are going to explore the surface area of cylinders and prisms. We're going to start with our entrance question. Please draw a 3D representation of a room that has dimensions 10 feet by 12 feet and 8-foot high ceilings. Please pause the video, draw it out, and we'll compare. Alright, if I know I have a room, I know it's going to be a 3D object. I'm going to start by drawing one rectangle, another rectangle slightly off center, and I'm going to connect all the corresponding corners. That's going to turn it into a 3D version of my room. I know I have 8-foot high ceilings, so I'm going to mark in the height is 8 feet. The room dimensions are 10 feet by 12 feet, so I'm going to go ahead and label in 10 feet and 12 feet. If you have the 10 feet and 12 feet switched, that's okay. It's still going to be the same representation of the room. Before we can start calculating the surface area of prisms, it would be helpful to talk about what they are. By definition, a prism is a polyhedron with two congruent parallel bases, and the other faces are known as lateral faces. Basically, in order for this to be a prism, we need to have two shapes across from each other that are the exact same size, exact same shape. Sometimes they're rectangles, sometimes they're on the top and bottom, or sometimes they're on the front and in the back. Another important term to remember is altitude or height. Altitude is a perpendicular segment that joins the planes of the bases, and the height is the length of the altitude. So if I have my 3D picture of the room again, and I have my top base and bottom base, this piece here that joins the top and bottom at 90 degrees is going to be the altitude, and the height is going to be the length of the altitude. So in our example problem, that was 8 feet. There are different configurations for our prisms. We could have a right prism where the top and bottom base meet at a 90-degree angle along the edge, or we can also have an oblique prism where the top and bottom base aren't directly over each other. They have to drop down to form the height on the outside of the figure. We can compute a couple different types of areas when dealing with prisms. The first type is a lateral area, which is the sum of the area of the lateral faces. To find this, we're going to take our perimeter and multiply by our height. So in other words, if we're talking about our 3D picture of our room again, the lateral area would be the area of the left and right wall and the front and back wall. So just the walls. In order to calculate our lateral area, we would take our dimensions, which the bottom has dimensions of 10 by 12, so we would calculate our perimeter, which is 44, and then multiply it by our height, 8, and we would end up with a lateral area of 352 square feet. We can also deal with the surface area, which is the sum of the areas of the lateral faces and the two bases. So this is going to be the walls, the ceiling, and floor. So let's go back to our entrance question, where we're finding the surface area of a room that has dimensions of 10 feet by 12 feet by 8 feet. So it's always a good idea to draw a physical representation, adding in our dimensions one more time. I like to think of this in terms of the room. So if I take a look at this left wall, I notice it has dimensions of 8 by 10. I also notice that the left and right wall together are going to be the same size. So I have two of them. So I'm going to calculate the area of the left and right wall as 160 square feet. Now I'll deal with the front wall. The front wall has dimensions of 12 by 8. I notice that the front and back wall have the same dimensions, so I'm going to go ahead and multiply that by 2 for a total of 192 square feet. Now we'll get to the ceiling. The ceiling has dimensions of 10 by 12. The floor is the same size, so I have two of them, for a total of 240 square feet. To find my total surface area, I'm going to add all of those together for a total of 592 square feet of surface area. In this next example, we're going to find the surface area of this triangular prism. Notice that the bases aren't on the top and bottom this time. The bases are the triangles that are in the front and in the back. So we need to find the area of the front and back triangle, as well as the three rectangles that make up the sides that join those two rectangles. So if we start with the rectangles, I notice that there are three of them, and they all have dimensions of 4 meters by 11 meters. I notice that they're all the same size, so I'm going to multiply that by 3, and I have a total area for the rectangles of 132 square meters. Now I'm going to deal with the triangle. I have two triangles, same size, same shape. So area of a triangle, I'm thinking 1/2 base times height, but I know I have two of them, so I'm going to multiply by 2. 2 times 1/2, that simplifies to 1. So now I just have my base times height. I notice that my base is 4 meters times my height. Well, my height isn't given directly, but if I take a look at this figure, I notice that it's 4 meters on each side, making an equilateral triangle. So each angle is 60 degrees. I can drop down my altitude, which then turns this into a 30, 60, 90 triangle. We'll remember our special right triangles pattern. Across from 30 degrees is x, across from 90 degrees is 2x, and across from 60 degrees is x root 3. Well, if 2x is equal to 4, I divide each side by 2, which gives me that x is 2, meaning that the height of my triangle is 2 times the square root of 3. So I'm going to plug that in for my height. 2 root 3 times 4, that gives me 8 root 3. And if I want to calculate my total surface area, I need to combine the area of my rectangles with the area of my triangles, and in terms of an exact answer, I would leave this as 132 plus 8 root 3 square meters. Next, we're going to focus on the surface area of a cylinder. So think about a soda can. We're going to find the area of the curved portion that goes around along the edges, as well as the two circles on the top and bottom. In order to calculate the surface area of the cylinder, we need to find the area of both circles on top and bottom, so 2 pi r squared, plus the area of that curved part that makes up the sides. Well, if it's unraveled, as shown in this picture, I notice that, alright, we have the height of our cylinder, and this portion that runs along the top edge, that would be my circumference. So I can think of that as 2 pi r. So I'm going to add in the dimensions of that rectangle. To find the area of that rectangle, I'm going to multiply 2 pi r times h. So the surface area of a cylinder, we would take 2 pi r squared plus 2 pi r h. In this third example, we want to find the surface area of this cylinder. We're told that the circumference of the cylinder is 16 centimeters and that the height is 20 centimeters. So let's think back to our formula. The surface area is equal to 2 pi r squared plus 2 pi r h. In order to calculate the surface area, I have my height, which I can plug in, that's 20, but I don't know my radius. I do know that the circumference is 16 centimeters, and I know that this formula for circumference is 2 pi r. So I'm going to go ahead and plug in 16 for 2 pi r to get r all by itself. I could start by dividing both sides by 2. That gives me 8 equals pi times r. I would then divide both sides by pi, which leads me to my radius is approximately 2.55 centimeters. Now that I have my radius, I can plug it in both parts of my formula. So I'm going to have 2 pi times 2.55 squared plus 2 pi times 2.55 times my height, which is 20. When I calculate this out, depending on how you round and when you round, you'll end up with approximately 360.74 square centimeters as the surface area of this cylinder. In this last example, we want to find the lateral area of our object. And you'll remember from before, lateral area is equal to the perimeter times the height. Well, I can calculate my perimeter by adding up the lengths of all edges. So I'm going to add up 10 plus 8 plus 25 plus 16 plus 14 plus 11 for a total perimeter of 84. Once I have my perimeter, my lateral area I'm going to take as 84 and multiply that by my height, which is 20. And I end up with 1,680 square units.